So this one has a higher than 2 degree as well, but we don't have a common factor in the coefficients. We only have common factor in terms of the variables. So I'm going to pull a y out of each of those and look at the trinomial left behind. We have a 4y squared minus 20y plus 25. Alright, so we've already factored it a little bit. Our goal is to factor the quadratic here if it factors. And so we're going to have to look at the AC method because we've got that 4 on the front of the y squared. So let's take 100, which is 4 times 25, and look at factors of 100 that add up to negative 20. Okay, so running through the AC method. Thank you. Nice work, Chloe. Negative 10 times negative 10. And that does add up to negative 20, so we are good. And let me split that middle term now. We still have a y on the outside, but we have 4y squared minus 10y plus 25. Okay. So we're going to just factor inside here by grouping. Get the y out front. Can pull a 2y out of that first set of terms, and that leaves a 2y minus 5. In the second set, all I could pull out is a negative 5. And you might be like, well, how'd you know pull a negative out? Well, I don't like starting these little quantities with a negative, so if this guy's negative, I usually take the negative with it. But that does change the sign on that representative at the end there where the 25 used to be. Which is cool because look at, we've got this common factor now. 2y minus 5, 2y minus 5. So, final answer. Y times 2y minus 5 and our leftovers were 2y minus 5. So that builds my other factor, right? But there's another way to write this more concisely, and that is, anybody know? Yeah, there's 2 of them. Very good. Just square it. That's as good as it gets. The degree is higher than 2. So I'm looking at each term to see if there's coefficients or factors even of the variable that I could pull out. In this case, pull a 3 out of every term and an x. And this leaves behind x cubed plus 8. And, it looks nicer, but all of a sudden you realize you're dealing with a sum of cubes. So this is really x cubed plus 2 cubed. The 3x will always be there, but we've got to do some work on this sum of cubes. And we saw that SOAP pattern the other day. So we're gonna jump into this one. So the pattern is, again, the 3x chilling out, a binomial times a trinomial. I need to build x cubed, so it's going to take x times x squared. To build the 2 cubed, I need a 2 times a 2 squared. And to get that middle magic term that cancels all the non-needed stuff from my distributive property, I simply multiply these 2 building blocks together and get 2x. The rest of this mystery unfolds just by using the SOAP little helper. So same, first sign is going to be the same as what? Same as the sign in your sum or difference. Was it a sum or a difference? So this was a sum, so we're the same, then we're opposite, then we're always positive. And we'll just do one quick cleanup step here. 3x times x plus 2 times x squared minus 2x plus 4.